winter night.
I'm sure you guessed there's more to adding and subtracting fractions than what I showed you last night. That was kind of just a little lead-in to where we're headed. The denominators could be polynomials. And in that case, what we need to do is basically, we're going to do the same thing we've been doing. We're going to factor first, if we can, and then we're going to get common denominators, and we're going to go ahead and add or subtract the fractions. Let's do a baby step. The first question, I have x plus 1 for one of the denominators and x for the other. Since they do not have any common factors, now focus on that comment, there's no common factors there. So the GCF in this case is x times the quantity x plus 1. I need to multiply this fraction by x plus 1 over x plus 1, and I need to multiply this fraction by x over x. In doing so, I'm going to get 3x squared over x times the quantity x plus 1, and I'm just going to do this second fraction here. So I would have 11x plus 11, and nothing can be done to that. That's prime, cannot be factored. You do want to check that. You want to ask yourself, can this be factored? And I know that that can't be factored. You could do the discriminant if you wanted to confirm that. Now in the second example, if you look at that, I see that again, these have no common factors. Because of that, my common denominator is going to be the product of x plus 2 times x plus 3. Now you don't want to multiply that out. You want to just leave that the way it is, and I'm going to multiply the first fraction by x plus 3 over x plus 3, and the second fraction by x plus 2 over x plus 2. You should get 6x plus 18 minus, now keep in mind I am subtracting this entire fraction, so that means these are going to work out to be negative. So that's going to be minus x minus 2 over x plus 2 times x plus 3. When I simplify that, I get 5x plus 16, which cannot be factored, over x plus 2 times x plus 3. So far so good? Let's move ahead. Now these do have a common factor, so you have to keep in mind that you want to factor if they do. This becomes 5 times x plus 2. I really don't need to worry about getting that part of the common denominator. The only thing I need to do is multiply that fraction by 5 over 5, and it will work out to be the common denominator that I want. Why don't you go ahead and do that question and number 4 and number 5, and come back and we'll tackle 6 together. For question 4, I got 23 over 3 times the quantity x minus 1. For number 5, I got 12 over x plus 4. Now that one you had to cancel out a common factor at the end, because you should have gotten maybe before that step a 12x over x times the quantity x plus 4. Well, I have a common factor here. They're attached by multiplication, and I can just cancel those out. Now let's look at number 6. I want to factor first, so I'm going to have 9 plus x times 9 minus x. And I already have an x plus 9 here, so I know that these guys are twins, but I do need to multiply this fraction by 9 minus x. Go ahead and do that and simplify it and see if you can get an answer there. I'm going to write out the full answer that I had. I had 6x minus 1 minus 18x plus 2x squared. Be careful with the distribution of the negatives. I can't say that enough. Just really have to be careful. Some of you might need to take an extra step there. My final answer is going to be 2x squared minus 12x minus 1 all over 9 minus x times 9 plus x. Let's move along to the next couple. Alright, so I would like you to pause here and work on these on your own. If you're struggling, I'm going to go through them step by step, so you can pause and kind of come back and check in. I just want people who need a little extra help to have it, but you should try and challenge yourself here, okay? So in number 7, I see this is a difference of perfect squares in the first fraction. So it's 9 over the quantity a plus b times the quantity a minus b. I'm not going to be able to cancel that, so I have to use that trick that I know about where I can switch the order with the subtraction and then take out a negative 1. The way I show that is I'm just going to put the negative with the 3. It's going to make it a lot easier and less complicated down the road. I multiply this fraction by a plus b over a plus b, and I'm going to get 9 minus 3a minus 3b all over a plus b times a minus b. In number 8, don't forget to factor first. So if you've been watching me, pause here and factor those denominators. I have x plus 2 times x minus 2, and this is going to factor into x plus 5 times x minus 2. So I know that what is not in common is this and this. I need to multiply the first fraction by x plus 5 over x plus 5 and the second fraction by x plus 2 over x plus 2. That's going to be a very big denominator. It's going to be the product of 3 binomials. But we really don't care about that, quite honestly, because we're just going to leave them in parentheses, and it's just going to look big and ugly. It's going to look like x plus 2 times x minus 2 times x plus 5. Now I have to worry about the numerators though, so when I multiply that out, I get 5x plus 25 minus, and keep in mind that is a minus 3x minus 6. When I simplify that numerator, it becomes 2x plus 19 all over x plus 2 times x minus 2 times x plus 5. You're golden! You did it! Survived! We'll work more with this tomorrow. Enjoy your evening.